Here we go. Oh, my favorite student. Number one, so we have two main concepts. Tyler, the concept of just plain old momentum, symbol P, is mass times velocity. I told you momentum is how much oomph, how much motion an object has. Then we have change in momentum, impulse. Change in momentum is mv final minus mv initial, and it's also force times change in time, but I'm lazy. I don't write the change in front of the time because physicists rarely do that. All right, here we go. Gibson, what's number one asking me to find? First thought I would go is it's not impulse, so I'll try mass times velocity. Oh yeah, they gave me a mass. They gave me a velocity. I can do that in my head. It's going to be 1,600 plus 1,760 units. Kilometers per second, Mr. Duke? Kilogram meters per second. And it did ask for a direction. I'll put an at symbol so you know that that n is newtons. It's north. I would give you 1 mark, half mark for the magnitude, half mark for the direction. Okay. Number 2. It wants the change in momentum. So there's 3 ways that I can find change in momentum. There's mv final minus mv initial. There's force times time. There's also just the definition of change in. What's change in anything? Yeah, I can also find the change in momentum just by going the final momentum, if I know it, minus the initial momentum, if I know it. I don't use that one very often, but I use it once in a while. Here, I'm looking at this. I think it's going to be mv final minus mv initial. I saw the word south. I saw the word south. Is there a direction change at all? Do I need to let one way be positive and one way be negative? I'm going to let south be positive then. So it's going to be 220. Looks like V final is 52 minus 220. V initial is 23. I have no idea what the answer is. $6,380? Is that what you said, Gerard? That's the magnitude. Units, kilogram, meters per second. South. Half mark for the 6380, half mark for the south. Ooh. Jesse, what do they ask me to find in part B? I could go F equals what? There is enough information that you can find the acceleration from this. But what did I just find? Yeah, which is not impulse. I could also say I know that force equals impulse over time. I looked at my impulse equation on my green sheet. I got the F by itself, divide by T. I'm going to do that because it's quicker. I'm going to get 6380 divided by 58. They just said magnitude. That means they don't care about the direction. So I'm just going to go answer button divided by 58. And, works out evenly. That's a fluke. 110 units. Direction. Didn't ask for it. If they had, positive, so also south, I guess. All or nothing for that one. Number 3, what is the magnitude? Okay, so number 3 is only asking for the magnitude of the change in momentum. It doesn't care about the direction. I looked at this. You know what? I underlined the word rest. I saw an initial velocity. I said, I think I'm going to go mv final minus mv initial. It's going to be 0 minus 80 times 18. It's going to be a negative answer. Now, because I said magnitude only, if you didn't put the negative, I would have to live with that because I didn't specifically say include a direction. I'll put it in there, though. 1,440? Is that right? What is the negative telling me? It's saying for this water skier to come to a stop, do they need to gain momentum or lose momentum? Yeah. So kind of Captain Obvious. That's what the negative here is saying. Okay. But they didn't ask for a direction, so again, I would accept the positive answer if you would just quickly crunch the number. Ooh, Noor, what's B asking me to find? It's asking me to find T. Don't write this down. Look up. I would have no problem if you went... there's enough that you can find A, I think, with a bit of cleverness, or you can find whatever you need. I'm going to use the impulse equation. I'm going to look at T equals impulse divided by force. One line. It's going to be negative 1440 divided by, now if I divide by 270, I'll get a negative time. Can time be negative? Why should I have made the force negative? Because whatever backwards is the impulse or change of momentum, the force is also backwards. They're in the same direction. But again, because I said magnitude only, I would have no problem if you just said, Duick, I know time is a scalar and it's going to be positive. If you did 1440 divided by 270, I'd be fine with that. I'm going to go 1440 divided by, geez, Duick, 270, because I know the negatives are going to cancel anyhow. Is it 5.33 seconds? So those are different ways that we can use the impulse equation as a lovely shortcut. Now let's get a bit fussier. Yeah, turn the page. Now it wants the impulse magnitude and direction. And I see the word east, but I also see the word what? I'm going to let one way be positive, one way be negative. For east and west, usually I let east be positive and I let west be negative. But I did say to you yesterday that sometimes I'll let final be positive and initial be negative. I don't care, Tyler, which method you used. Tyler, what's this question asking me to find? Yep. So I wrote change in momentum. Which version? I see a final velocity. I see an initial velocity. I think I'm going to go mv final minus mv initial. M. Ooh, nice try, Duick. It's not 170. 170 grams. How many kilograms? 0.17. Good. So it's going to be 0.17 times negative 43 minus 0.17 times positive 22. I have no idea what the answer here is. 0.17 times negative 43 minus 0.17 times positive 22. I'm missing a 1, aren't I? Caught that before I hit enter. Do you get 11.05 positive or negative depending on which way you let be positive or negative? And if you rounded that to 11.1 to 3 sig figs, I'm fine with that. I'm going to write the whole thing just because I know I'm going to be using it for the next question. What does the negative tell me? Because it said magnitude and direction. Which direction have I let be negative? Good. 11.05 kilogram meters per second west. I would give you 1 mark for the magnitude, 1 mark for the direction. Yes? Okay. Oh, if you let west be positive, you would have got positive 11.05, and you still would have said west. What's the average force, magnitude, and direction? I said I can find force from impulse by going delta P impulse over time. If I use my negative 11.05 divided by 0.0225 divided by 0.025, not 225, just 0.025, I get negative 442. Now I'll report that with a direction. 442 newtons at which way? I hope not north. What's my direction? Negative is west in this question. Does that make sense? Yeah, here's what we're saying. A hockey puck came sliding east. If it ends up going to the west after you hit it, the force must have been to the west because the hockey stick had to stop the puck and then turn it around and get it to go in the opposite direction faster than it came in. Yeah, you've applied a fairly sizable force to the west. Same as before. 1 mark for the magnitude, 1 mark for the direction. Number 5. Nice try, Mr. Dewick. 0.15 kilograms. I see the word east and I see the word west again. So I chose to let east be positive, which means I guess this force is negative. It's to the west, if I read the question very carefully. Why didn't I put a negative in front of the 7.5 times 10 to negative 4? So what can you know about time? Scalar. Okay, good. What impulse? I think this time I'm going to find the change in momentum by going force times time. It's going to be negative 20,400 times 7.5 times 10 to the negative 4. Negative 20,400 times 7.5 times 10 to the negative 4. I got negative 15.3, which if I report that is going to be 15.3 units. If you said kilogram meters per second, I'm fine with that. I chose to write Newton seconds just because I'd gone force times time to get this. That was in my brain. But if you said kilogram meters per second, that's fine. Direction. I got a negative answer. Which direction is negative? Again, I would give you 1 mark for the magnitude, 1 mark for the direction. B is going to be a bit trickier, I can tell, because Mr. Dewick made it worth 3 marks, which probably means it's got an extra step or 2. They want you to find VF. Again, let me emphasize, I would have no problem, don't write this down, if you went VF equals question mark. Well, I know VI. I know T. I can find A by going F equals what, MA. And if you do that, totally fine. I'm lazy. If I can do something in fewer steps, I will. I started out by saying impulse. Well, actually, I started out by saying this. Impulse equals mv final minus mv initial. What am I trying to get by itself? Vf. What's going to drop down like a domino? The delta, leave myself some room, Mr. Dewick. Change colors. The delta P drops down like a domino. How would I move the MVI over? Then what, Josh? That is yet another equation for final velocity. I'm not going to memorize it. I can figure it out. And now it's going to be sticking the numbers. I'm going to have negative 15.3 plus, what was the mass, Mr. Dewick? 0.15. VI, positive 39. All divided by 0.15. Bracket, negative 15.3. I guess I could use my answer button. Plus 0.15 times 39. Close off the top. Divided by 0.15. $63? Is that right? Yeah? No? Yes? People nodding? I got negative 63, so if I report that 63 meters per second at west, to the west. Is that the right answer? My brain is thinking it's not. You got something different? You got that? 63? Negative 63? Let me just double check my math, my typing. No, maybe I am good. Maybe I'm just misremembering. I would give you 1 mark for the magnitude, 1 mark for the direction, and then I would probably give you 1 extra mark if I saw this equation somewhere along the way. I'm just curious, is that what I got this morning, Mr. Dewick, on the take-home quiz for the answers? 63? Maybe it was, and I'm just not remembering correctly. Oh yeah, I got the same thing. We're good. Whew, got me worried for a second there. What's the correct answer for number 6? Why 0? Shouldn't it be 2,500 times 34? That would be if I just said find the momentum. I didn't. I said find the change in momentum, the impulse. And if you're not speeding up or slowing down, 0, baby. Can you give yourself a lovely score, please, out of 15? If you need to lawyer with me, now is the time.